In this episode, we connect Linux administration to the way modern teams build and deliver software, because many security and reliability problems now happen long before a program ever runs on a production server. Continuous integration and continuous delivery, CI/CD, is the phrase used for automated workflows that build, test, and prepare changes for release, and GitOps is a related approach that treats a version-controlled repository as the source of truth for how systems should be configured and deployed. The Linux Plus exam touches this vocabulary because Linux systems increasingly live inside automated delivery ecosystems, and administrators must understand how changes flow from a developer's workstation to a running service. This is not about becoming a programmer. It is about being able to reason about how automation affects risk, how controls can be applied early, and how failures can be traced back to a specific change. You will hear terms like pipelines, shift-left testing, and DevSecOps, and the exam expects you to recognize them as parts of a single philosophy. Build reliable, secure outcomes by making change controlled, testable, and repeatable. By the end, you should be able to explain these ideas clearly and connect them to why Linux environments become more stable when change is treated as a managed process rather than a series of manual interventions. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. The most important problem CI/CD solves is the chaos that happens when changes are applied inconsistently or without proof that they work. In older styles of delivery, teams might gather many changes, push them all at once, and then spend days troubleshooting because nobody knows which change caused the break. That big batch approach makes outages more likely and makes security flaws harder to catch, because review and testing are rushed near the end. CI/CD pushes teams to integrate changes more frequently in smaller increments, and each increment is automatically built and tested so problems are detected closer to their source. This reduces the size of unknowns, because when a change breaks something, you can usually identify it quickly and fix it before it becomes part of a larger pile. For Linux administrators, this matters because production systems are the final destination of many changes, and stable delivery processes reduce downtime and reduce the urge to apply risky emergency fixes directly on servers. The exam often frames this as reducing errors and improving consistency, and that framing is the core value even when the words vary. A pipeline is the structured path a change travels through as it moves from code to a built artifact to a deployed service. The pipeline concept matters because it provides a repeatable sequence of stages, such as building, testing, scanning, packaging, and deployment, each with defined outcomes and criteria for success. Beginners sometimes imagine a pipeline as a single script, but it is more helpful to think of it as an assembly line with gates, where each gate must pass before the change can move forward. This gate idea is central to security and reliability because it allows teams to enforce rules like refusing to deploy if tests fail, refusing to deploy if known vulnerabilities are detected, or refusing to deploy if required approvals are missing. A pipeline also creates a log of what happened, which supports traceability and incident response. If a deployment causes a problem, pipeline records help you answer what changed, when it changed, and which tests were run. On the Linux Plus exam, pipeline language is often tied to automation and repeatability, and you want to connect it to the idea of controlled stages rather than to a particular vendor product. Continuous integration is primarily about merging changes frequently and verifying that the combined result still builds and passes key tests. The reason this matters is that software and configuration are rarely independent, and a change that works in isolation can fail when combined with others. By integrating frequently, teams reduce long-lived branches that diverge and become hard to reconcile, which lowers the risk of painful last-minute merges. Continuous integration also encourages automated testing to be treated as a first-class requirement, because if you integrate frequently, you need quick feedback to keep the flow moving. For infrastructure and Linux configuration, integration can include validating configuration files, checking syntax, and verifying that changes are consistent with baseline policies. The exam expects you to recognize that continuous integration is about early, frequent verification of changes, which improves reliability by catching issues before they are deployed. When you understand CI as frequent merge plus automated verification, you can interpret many questions that describe how teams keep changes from breaking shared systems. Continuous delivery, and sometimes continuous deployment, depending on how strict the automation is, focuses on making releases predictable and low risk by keeping the software in a deployable state. The key idea is that after passing the pipeline stages, a change is ready to be released with minimal additional work because the pipeline already built, tested, and validated it. In a continuous delivery model, deployment may still require a manual approval step, while in a continuous deployment model, deployment happens automatically once gates are satisfied. For Linux administrators, this matters because predictable deployment reduces ad hoc changes on servers and encourages repeatable releases, which supports stability and auditability. It also means that many issues you might have previously fixed manually on a server should instead be fixed in the code or configuration repository, so the fix becomes part of the next release. That shift reduces drift and ensures the fix is applied consistently across environments. The exam often uses CD language to describe automating delivery and keeping systems in a consistent deployable state, so you should associate it with controlled, repeatable release readiness. Shift-left testing is a phrase that means moving testing and security checks earlier in the lifecycle, closer to where changes are created. Instead of waiting until the end, when changes are expensive and stressful to fix, shift-left thinking says you should catch problems as soon as possible, ideally before they ever reach a shared environment. For example, if a configuration change would weaken an access control, you want to detect that during review or early pipeline scanning rather than after it is deployed. If a software dependency introduces a known vulnerability, you want to detect it during build time rather than after an incident. Shift left is not only about catching bugs, it is about reducing the cost of correction, because small early fixes are cheaper and safer than emergency late fixes. This ties to security because attackers often exploit small gaps, and the earlier you prevent those gaps from reaching production, the safer the system becomes. On the exam, shift left is a vocabulary hint that the right answer is the one that moves validation earlier rather than adding last-minute checks after deployment. DevSecOps is the vocabulary that describes integrating security into development and operations workflows rather than treating security as a separate final inspection. The core idea is that security should be baked into the pipeline and into daily practices, so security controls are automatic, measurable, and consistent. This does not mean every developer becomes a security expert overnight, and it does not mean operations teams become irrelevant. It means security requirements become shared responsibilities supported by automation, good defaults, and review processes. In practical terms, DevSecOps includes things like scanning for vulnerabilities and dependencies, checking configurations against policy, validating container images, and ensuring secrets are handled safely, all as part of the same delivery flow. For Linux administrators, DevSecOps also implies that access controls, logging standards, and hardening baselines should be expressed in code-like forms so they can be applied consistently. The exam uses DevSecOps language to test whether you understand that security is integrated into pipelines and practices, not bolted on at the end. If you can describe DevSecOps as security integrated into the delivery loop, you have captured the exam intent. GitOps is a particular approach to applying these ideas to infrastructure and configuration management, and it is built on the principle that the version-controlled repository is the source of truth. In GitOps, changes to infrastructure or application deployment are proposed as changes to repository files, reviewed, and then applied by automated systems that reconcile the real environment to match the repository state. The important concept is reconciliation, which means the system continuously checks whether reality matches the declared state and corrects differences, similar to desired state configuration management. GitOps helps reduce drift because manual changes made outside the repository are treated as deviations and are either reverted or surfaced for investigation. It also improves auditability because every change has a commit history, review trail, and potential rollback path. Beginners sometimes interpret GitOps as simply using Git, but it is more than that, because it includes automation that enforces repository state as the authoritative description of the environment. For Linux Plus understanding, GitOps is a way of describing controlled, versioned, automated operations where the repository drives deployments and configuration. A common misunderstanding is to assume that pipelines and GitOps eliminate risk entirely, but the reality is that automation changes the risk profile rather than removing risk. Automation reduces manual mistakes and improves consistency, but it also increases speed and reach, which means a bad change can propagate quickly if review and gates are weak. This is why secure pipelines emphasize guardrails like code review, automated testing, staged rollouts, and clear separation between environments. Another misunderstanding is believing that shift left means shifting everything left and ignoring runtime monitoring, when in fact good security includes both prevention and detection. You still need logs, alerts, and incident response capabilities, because no pipeline can predict every new attack or every unexpected runtime condition. The best mental model is that pipelines and GitOps reduce the probability of common failures and catch many issues early, while runtime controls handle what slips through and what emerges later. When you can describe both the benefits and the remaining needs, you show a balanced understanding that exam questions often reward. For Linux administrators, these concepts change daily work because they encourage fixes to be made in the controlled source of truth rather than by directly editing production systems. If a configuration file needs a safer setting, the correct habit is to change the template or repository definition so every system receives the fix through the pipeline. If a service needs a new policy, the correct habit is to update the declared state so it is applied consistently. This reduces configuration drift and makes troubleshooting easier because you can compare what is running to what is declared and then identify whether the issue is a drift problem or a definition problem. It also supports faster recovery because rebuilding and redeploying become reliable options instead of last resorts. The exam often describes these benefits as consistency, repeatability, and reduced manual errors, and you should connect those words to the pipeline-driven approach. When you see a scenario where manual changes cause inconsistent environments, the correct direction is usually towards CI/CD and GitOps style control. Traceability is another thread that ties CI/CD and GitOps together, and it is particularly important in security contexts where you must explain what happened after an incident. When changes go through pipelines and repositories, you can often trace a running configuration back to a specific commit in a specific pipeline run. That trace supports root cause analysis, because you can see what changed and whether tests and checks passed at the time. It also supports accountability, because you can see who proposed the change and who approved it. In contrast, manual changes made directly on servers often leave weak evidence trails, and those weak trails slow down investigations and increase the chance of repeating the same mistakes. This is why security teams care about change control and why DevSecOps pushes security controls into pipelines where evidence is naturally produced. The exam may test this indirectly by asking which approach improves auditability and repeatability, and traceability is the reason those improvements happen. It is also worth recognizing how these ideas affect the vocabulary you will hear, because exam questions often use vocabulary as cues. Words like pipeline, stage, gate, build, test, scan, deploy, and rollback are common signals that the question is about CI/CD thinking. Words like repository as source of truth, reconcile, desired state, drift, and pull-based deployment are common signals that the question is about GitOps thinking. Words like shift left, automate security, integrate security, and continuous compliance are common signals that the question is about DevSecOps thinking. Your job is not to memorize a slogan, but to map the vocabulary to the underlying intent. Reduce risk by moving checks earlier, reduce drift by using declared state, and reduce outages by making change smaller and more controlled. When you train yourself to look for intent behind the words, you avoid being tricked by answers that sound technical but do not address the problem described. That skill is especially important on Linux Plus because many questions test reasoning and trade-offs rather than deep syntax knowledge. By the end of this episode, You should see CI/CD and GitOps as two connected approaches to making change safer, more predictable, and more defensible. Pipelines provide structured stages with gates that build, test, and validate changes before they reach production, reducing big batch surprises and improving traceability. Shift-left testing moves validation and security checks earlier, so mistakes and vulnerabilities are caught when they are cheapest to fix and least likely to cause outages. DevSecOps vocabulary describes the cultural and technical shift where security becomes integrated into the delivery process rather than added at the end, supported by automation, review, and consistent baselines. GitOps extends these ideas to infrastructure and deployment by using a version-controlled repository as the authoritative description of desired state, and by using reconciliation to reduce drift and enforce consistency. When you can explain how these pieces fit together, you will recognize the exam scenarios that describe modern delivery ecosystems. And you will also understand why Linux administration increasingly involves working with controlled change systems rather than relying on manual edits on production machines.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.